Hi YouTube and welcome back to my channel Cloud Space with Siba, where we focus on showcasing how we build real-world applications on AWS. And in this particular video I'm going to be doing a walkthrough of how I would architect or design an ECS cluster that's going to be a production cluster whereon we will run a containerized application. Be- Before we move on to that, please don't forget to subscribe, like the video, and share it. Don't forget to add your comments, particularly on a design video like this where there's so many ways to do it. Please share how you would approach it, and I'll be happy to read that in the comment, right? So, uh, some things to take into consideration as we will do this design is, first of all, networking, meaning where our cluster itself will live, and the various components that will be needed to ensure that our cluster is running smoothly. The second thing to consider is caching, meaning where possible will temporarily store requests to make them easily available. Then it's security. Then the next thing is auto scaling, making sure that our cluster um, is consistently accommodating the amount of requests that are coming in, the load that's coming in. Then the fifth thing we'll look at is the cluster itself, how that will be set up, including Fargate, and then lastly the containers themselves, right? So if we start off with the network, obviously our networking service is a VPC, which is a virtual private cloud. And what the VPC will really do is that it'll be the networking backbone for our entire workload. And within the VPC, how I'm thinking of doing it is by having a CIDR of 10.0.0.0/16, and then within the subnets themselves have a /24, and that should give us way um, more than enough IP addresses to work with, particularly for the tasks that we'll run in our cluster, and I'll get to that later. But the VPC itself will be really divided into two for now. There is a possibility of adding another set of subnets should there be a need to perhaps run the databases on this very network itself. But in terms of the cluster, there's two there's I have public subnets and private subnets. Public subnets, this is where we'll have certain components that can be exposed to the internet and therefore have an IP address. And then private subnet is where we will have components of our cluster that we don't want to expose to the real world, right? So within the public subnets, there's two components that are going to go in here. First is the net gateway, and essentially the net gateway will allow for our cluster components that are in the private subnets that need to communicate to the internet to be able to do that, right? So it'll act as that mechanism. Then another thing we'll have is an application load balancer. And this is quite important because what the load balancer will be, it will serve two purposes. Firstly, it'll be the gateway to the cluster itself. So traffic, for example, our users will come in, we'll send requests to that load balancer, and then it'll be the gateway to the cluster. That's on the one hand. On the other hand, the load balancer will also act to distribute traffic evenly, if you will, across the services, and I'll get to that as well. So that's kind of like the networking aspect of our class. It's very simple, right? It's a VPC. It's got two public subnets, two private subnets. And if you notice here, each of these would be sitting in their own availability zones. Then obviously we'll have the net gateway for communication between the outside internet and the private component sitting in the private subnets, and then there's the load balancer. Now, remember the load balancer is they're designed to be highly available, so they'll take as much of the available zones that are available to get to high availability, which is absolutely fine in that we have more than one availability zone, so we're good with that. Then the other thing I would have in front of the load balancer is a Cloudfront distribution. Remember, Cloudfront is a CDN, which means it caches requests or certain assets and makes them available to users that are close enough to those edge locations very quickly, which means it improves the performance of our overall application by giving more speed, right? And so I would have the Cloudfront distribution here, and it would have and then I would point it to the load balancer here, and that would kind of take care of that CDN caching layer for the load balancer. All right. Now, with networking and caching taken care of, the next thing would be to think about the cluster setup itself. I'll come back to security and autoscaling because the cluster needs to exist before I can actually do that. So in terms of the cluster itself, I'll have an ECS cluster, as you can see here. And obviously within our ECS cluster, there will be containers that are running. Now, the cluster itself is going to be running in the private subnets here. And that puts us in a very interesting position because it means that the tasks that are going to be running here won't be assigned public IPs. And that's okay, because even though that's the case, we'll find a way to get traffic to our tasks, which are essentially our containers. But the cluster itself is very straightforward. It's just a cluster. It's a logical grouping of all the components that will help run our workload, and it'll be in the private subnets like I've mentioned. But in terms of the compute layer, excuse me, in terms of the compute layer, we use Fargate as a capacity provider. Remember, with ECS, we can use one of two launch types. It can either be Fargate or it can either be EC2. We're not going to deal with EC2 because we just don't want to manage we don't want to do any server administration. We just want to be able to run our workload and run it very quickly, and be able to, and the way we do that is with Fargate. So there it is. Fargate will be the capacity provider. Fargate is serverless, which means it takes care of that. Not only that, but it will also take care of the auto scaling that we want, at least from a compute level, which puts us in a position that when we configure the containers themselves, all we need to think about is what amount of resources is that particular container going to need, and under the hood, Fargate is going to figure all of that out for us, and I like that, right? So that's the simple nature of the cluster itself. Now, the cluster containers themselves, during the init phase, will get all of the images from ECR, which is Elastic Container Registry. It'll be private, but ECS will have the permissions to be able to pull from that repository, and that'll take care of where we store our Docker images and where they get pulled from. Perfect. Now, within the cluster itself, our tasks, ergo containers, will be monitored, tracked, and started by a service. A service will have a sort of like a twofold responsibility. Number one, it'll do all of the monitoring, the starting and restarting of containers and tracking them. But also, on the other hand, it'll also be the entry point to those running containers, right? So that's why we have an arrow here that points obviously to the tasks, but also there's another arrow from the load balancer to the service. Now, our application is going to have more than one service. So the question becomes, how do we have the load balancer route traffic to the specific service that's required by a particular request? So if you look at our load balancer here, we're going to use a path-based routing strategy, meaning we'll use the path in the host name to determine what service is going to receive the traffic. So for example, we'll have within our load balancer the service name / an asterisk, and what that will tell our load balancer is that requests with this host name, or with this path, in the host name, are going to be directed to a particular service, and that's how we'll route traffic to all of our services. And when traffic gets routed into those services, each service will then take care of sending the traffic to the particular containers that it's tied to, right? Perfect. Now, there's two things that we'll consider, or I'll consider, for the service itself, and it comes down to the parts that I said I'll come back to in terms of security and autoscaling. For each of our services, we'll have a security group, and it'll allow traffic on certain ports, and that's really the security aspect. It's that simple. There's nothing more complicated than that. And then in terms of autoscaling, we'll configure application autoscaling, and what that will do is that it'll watch for certain metrics, whether that be CPU or memory. We'll set up for both. And what will happen is that as traffic is coming into the service and it's consuming resources within Fargate, CPU or memory, once that consumption hits a specific or goes over a specific threshold, what application autoscaler will do is that we'll configure it to then add more services. Add more services to then be able to better handle the load. Once the consumption goes below that threshold, we'll then configure it to then reduce the amount of services that we have running, so that obviously we use less compute, which means we're paying less. That's the role of autoscaling. So because Fargate handles the scaling of the compute layer, we'll handle the scaling of the services via application autoscaling, right? Now, so that takes care of autoscaling, and that takes care of security. Now, the tasks themselves are going to have two parts, right? The tasks, we're going to have the task definition, which is the blueprint of what is needed to run our containerized application. But also, for every task we provision, we'll also provision a log group. And essentially, a log group that's a Cloudwatch function where our logs are going to be written to by the application. And so every time something happens within the application, all of those logs will be written to that specific log group, which obviously will sit within Cloudwatch. And what this will allow it to do is that within the cluster itself, in that service, we'll be able to look at be able to, I guess, observe things that way, but also be able to know what issues are existing within that particular service by looking at the logs. It's a simple case of allowing us to debug. Now, another thing we're going to have, that I'm going to have as part of this design, is within Cloudwatch, we're going to set up Cloudwatch events and Cloudwatch alarms. So what we want to do is, when our tasks are crashing or they are consistently hitting certain thresholds, what we want to do is we're going to send a notification to SNS, which will send a notification. We're going to send an event to SNS, which will send a notification to our DevOps team, so that they're able to be able to look at what is it that's causing that application to consistently be hitting those thresholds. Is it traffic or is it something else? So this is sort of like a alerting strategy for the teams that are involved within the cluster. So yeah, so this is our simple design for this is how I would approach designing an ECS cluster. I hope you found value in this. I'd like to know, how would you approach it? How would you design the ECS cluster? What components would you have? What would you take out of this? What would you prioritize over what? And share that in the comments below. But other than that, I hope you found value in this video. I look forward to coming back with another video around ECS clusters. In fact, I'm at the moment preparing to upload a video where we create an ECS cluster from scratch using Terraform. Yeah, so thank you so much, guys, for watching, and please don't forget to subscribe, to like, and to share this video, and also to share your thoughts in the comments as well. Thank you so much, and I'll see you in the next video.